Let's consider a problem regarding circular linked list. The problem tells us, given a linked list, determine where does the circle happen. We know a circular linked list to be this form, but a circular linked list can also be in this form when we start from some head, go to some node, and then at that node we start to have some circles. Okay? So it's not the case that we always start from the head and then the circle ends also at the head. It can start somewhere else and end at somewhere else too. So let's start the problem with considering this guy here. It's simpler than this one than this case. So let's just talk about this one for now. If we have a circular linked list that starts at the head and ends at the head, our job is pretty easier. Let's consider this one as a racetrack, and let's say that we have two people running on this racetrack. The first person, P1, goes with a speed of 1 unit, and P2 goes with a speed of 2 units. When are they gonna meet each other again? Well, when P1 goes n units, when like the racetrack is n units long, P1 needs to go n units around the circle, and P2 needs to go 2 round around the circle, because P2 has the speed of 2 and P1 has the speed of 1. So P1, if P1 goes n units and P2 goes 2 n units, they're gonna meet each other. And if P1 goes n units, he is gonna end up again at the beginning of the linked list. And if P2 goes 2 units, he is going to end up at the beginning of the linked list as well. So the head of the linked list is going to be where they're going to meet each other again. In the case of in the case of second form of linked list, when you when the circle happens somewhere other than the head, we have the same situation almost. But we start k units before the circle happen. So the circle happens right here. And we start k units before the circle. So it makes sense that they're gonna meet each other k units before the start of the circle. So they're gonna meet each other here. Exactly k units before the beginning of the circle. So 1, 2, 3. Okay, k units before the start of the circle. Now let's see if it makes sense in some kind of formula. It's not complete formula, but in some kind of formula. So let's say we are talking about P1, and before I continue, let me tell you that the length of this circle, okay, this path is n. Okay, so it's not the length of the whole linked list. The length of the circle is n. Okay. If we tell P1 to go n units, this P1 is gonna end up at n minus k, because the length of the circle is n and he started k units before. So P1, it's gonna end up at n minus k. Now if we tell P2 to go twice as this this distance, P2 is gonna go n minus k, okay, because he needs to start from here, goes n units, so he's gonna end up at n minus k, and then we're gonna tell him to go 2 rounds because of this logic that I explained you before. So P2 needs to go 1 round around the circle again, and until he meets with P1 again. So P2 needs to go n minus k plus n units. Okay, which is going to be the same thing as 2n minus k plus k, if that one makes more sense. So that's the way that we find where they're going to meet. Okay, now at this point P2 and P1 are at the same spot. Okay, to find the point that the circle starts, we need to tell P2 that, okay, take it easy and don't go twice as fast. Go just with the speed of 1. And we put it at the beginning of the linked list, at the head of the linked list. Okay, so we take it away from this guy and put it here. Then we tell P1 and P2 both go in a speed of 1. So P1 is going to go here, P2 is going to go here. P1 is going to go here, P2 is going to go here, and then P1 is going to go here, and P2 is going to come here. So they're going to meet each other. And this point is going to be the beginning of the circle.